Let's end our discussion of Chapter 3 by looking at 8 common mistakes that you want to avoid. One thing to be careful for is to watch out for categorical data that look numerical. Often, you're going to have categorical data that's actually coded numerically, but it doesn't actually have a numerical meaning. For example, sometimes gender might be coded with zeros and ones. Zip codes or telephone area codes would also be numerical looking, but they actually are just labels and therefore categorical. When you have categorical data, it doesn't make sense to summarize using the mean, the standard deviation, the median, or the interquartile range. So avoid the temptation to do that. Also be aware that measures of center don't tell us everything. Measures of center, such as the mean or the median, do give us a sense of what a typical value should be, but that's only one characteristic. You really want to know information about the variability and the distribution shape so that you have a better sense of the behavior of that variable. Also be aware that data distributions with different shapes can have the same mean and same standard deviation. Look at these two distributions. Both of these have a standard deviation of 2 and a mean of 10, but you can see that they are very different looking shapes. We talked about this already, but it's worth repeating that the mean and standard deviation can be sensitive to extreme values in the data set, particularly in small sample sizes. If your data is skewed or has outliers, you really should use the median and the interquartile range when describing the center and variability. Next, measures of center and measures of variability are going to describe the values of a variable, but not the frequencies in a frequency distribution. So you're not going to know how common those values are. You're simply going to know where they're centered and how much they spread out. Also, when using box plots, be careful when you're using small sample sizes. Since the box plots are conveying information about the center, the variability, and shape, if you have a small sample size, interpreting shape information from that can be problematic. So, for example, if you have a small data set, using a box plot to determine if it's symmetric or skewed is going to be really difficult because you only have a few observations in each section of that box plot. Another thing to be careful is that the empirical rule is only for data distributions that are mound-shaped and approximately symmetric. You can't assume that that's going to be the case. Not all distributions are mound-shaped. So when that's not true, any of the decisions that you make with the empirical rule are going to be incorrect statements. And then finally, watch out for those outliers. Anytime you have unusual observations in a data set, it's important to know that about the variable under study, but you have to be careful when you're considering these outliers because they are not going to be typical. They're important, but they don't represent what's typical of your distribution. Outliers will cause problems because some of those summary statistics are influenced by our outliers, and as we move on, some of the methods for drawing conclusions from data are not going to be appropriate if we have a data set with outliers. So as we progress through this course, it's going to be tempting to ignore the shape of our distribution and the identification of outliers. But it's important that we always come back to chapters 2 and 3 to make sure that we recognize the shape of our distribution and the presence of outliers before we start making conclusions from the data.